So most of this should be reviewed. So if I'm looking at transformations of polynomials, remember when we did all the parent functions, if this was x squared, what was this one? Negative x squared, okay? And then if you had x squared, how do we move it up? Yeah, you put a plus on the end of it, or how do you move it down? And then how do we move it left and right? Remember, that was backwards. That's all we're doing today, but instead of with the parent function, we're doing it with every polynomial. So what was this function when it's reflected about the x-axis? What would this be if I reflected it? Yeah, it'd just be negative x squared. That's reflecting it about the x-axis. How do I move it up? Let's just say, for example, I wanted to move it up 4. What would this function be? F of x equal x squared plus 4. That moves that original function up 4. How could I move this function to the left? Move it to the left 5 units. Okay, so this will be f of x equal, how do I move it to the left 5? Plus 5 squared. Okay, that's what we did with all of our parent functions. All we're doing today is the same thing with a polynomial. Okay, so look at this one. Here's my original. F of x equal x to the 4th plus 8x. Here's my transformation. Okay, has this been reflected about the x-axis? No. Has it moved horizontally? No. If it moved horizontally, so there's no horizontal shift, my x's would have to become x plus 1s or x plus 2s, okay? But it didn't. So what is the only thing that has happened? To get from here to here, what happened? Yeah, it went down. The graph of that thing went down 15 units. That's all that happened, okay? So this is the same thing we did with the parent functions, doing it with a polynomial. So let's look at the next one. If I'm transforming from f to g, has it been reflected about the x-axis? Answer is yes. How do you know that? There's a minus sign that came in, so the sign changed. Did it move horizontally? Yeah, so if I change my x to an x plus 13, that's moving it which direction? Left. So this thing moved to the left, 13 units. Did it move up or down? No. If it moved up or down, there would be something like this tagged on the end of it. That would be what moved it up 5, but that is not there. So there's no move up or down. Pardon me? Yeah, the negative that's in front. Okay. Let's look at the next one. Has it been reflected about the x-axis? Yes, the key is I had a positive here and I've got a negative here. The same thing would happen if this one were negative or that one were positive. The sign has changed. So this is reflected about the x-axis. Did it move horizontally? Yes or no? Okay. What makes you think it moved horizontally? Okay, I see an x minus 4 and x minus 3, but what do I see over here? Same thing. So it did not move. Okay, so there is no horizontal shift. Okay. Is there a vertical shift? Yes. It is what? Up 1. Okay. Does this feel familiar? I mean, it should. Okay. Let's look at the next one. Has this been reflected about the x-axis? Yes, because of that negative sign. Did it move horizontally? No. What I'm looking at, I've seen x to the 6, and I've got x to the 6 here, so I don't see x plus 1 to the 6. So there's no horizontal shift, but it moved where? Up by 7. Okay. Now this is the one that conceptually people have a little bit of challenge with, but we just have to sort of decode it right. Did it reflect about the x-axis? Yes, because I see the negative sign. Okay, let's go to the vertical shift. Did it shift vertically? It went what? Up 1. Okay. Now here's where I have to do some thinking. It has moved left or right. What is my clue that has moved left or right? Yeah, the numbers have changed. Okay, so how do you get from a negative 6 to a negative 5? What do you have to do? You have to add 1. What happens if I add 1 here? I get that. Okay, so that's what happened. I added 1 to each of those numbers. If I add 1 to each of those numbers in the parentheses, I'm moving this graph where? Left. Left, how many? 1. So this moved to the left by 1. Okay? So what happened here was I tried to investigate what can turn an x minus 6 into an x minus 5. That would be when you add 1. What would turn an x plus 1 into an x plus 2? That would be when you add 1. So adding 1 to both these numbers on the x-axis is the equivalent of moving to the left 1. Yes? It moved to the left. Remember, on the x-axis, plus is moving it left, minus is moving it right. If we had, it's opposite of what you would think, okay? So like, for example, when we started graphing, when we had x squared, this moves us to the right, okay? This moves us to the left, okay? It is opposite on the x-axis. On the y-axis, positive numbers move you up, negative numbers move you down, okay? So this is the one that people struggle a little bit with, but I think you just have to decode how did you get from one to the other, okay? Has this been reflected about the x-axis? No, I don't see any change of sign. Something has happened horizontally, okay? So I look and see, what could turn an x into an x plus 5? Adding 5. What could turn an x plus 4 into an x plus 9? Adding 5. What could turn an x minus 6 into an x minus 1? Adding 5. These numbers have to all match. What if I change this one by 5, this one by 4, and this one by 3? It's basically a whole different function, okay? It's not like I picked the function. I'm saying this is picking the function up. So plus 5 is moving me where? To the left. So this is left 5. So I'm basically saying pick this function up and move it to the left 5. No, if I'm giving you on this transformation, there is a transformation there. Otherwise, it's just two separate functions, okay? And then is there a vertical shift on this one? Yeah, there is no vertical shift on that one. Do you see what I did there? I keep saying like this, people struggle with this or it's more challenging, but I don't want to put that on you. Is it straightforward? Is it? Okay. Like I said, it's just a little bit different to see that. Has this been reflected? Yes. Okay. And then if I look at, has it moved left or right? No, because I see the same numbers here. So there's no horizontal shift. And then what else has happened? Yeah, it went up by 8. Okay. And let's look at the next guy. So if I go from F to G, was it reflected? Yes. Okay. Horizontally. So let's just try to figure out what happened. What turns an x into an x minus 3? Minus 3. What turns an x plus 4 into an x plus 1? Minus 3. What turns x minus 6 into x minus 9? So if I do a minus 3 for each of those things, I'm moving it where? 3 to the right. Okay. And then what does that 17 do on the end? Yeah, up 17. Okay. Now that should just start to feel really like it did with the parent functions. Is that sort of accurate? Okay. And the other kind of transformation you'll need to do is something visual. How do I get from this graph to that graph? Okay. If you're like me, to me this is harder. The visual transformations. I think you may have seen this in geometry. So let's just look at this. This function is starting down here and it's ending up here. So I don't have to ask this, but what is the degree of this function, even or odd? This is an odd degree. Okay. Leading coefficient, is it positive or negative? Positive. So that's a fair game question to ask. Okay. Leading coefficient is positive. What about this guy? So, and then this would be over here. This is still going to be an odd function. So it has an odd degree. What about the leading coefficient on this guy? It's going to be negative. Yeah, because, you know, odd degree with a positive is going to look like this. Odd degree negative is going to look like this. So this has to have a negative coefficient. So has this function been reflected about the x-axis? Yeah, it's been flipped. So I know that has happened. Okay. Now, here comes the challenge part, or what I really need to do. I need to figure out what has changed. So I want to identify a point that I know. So I know where this point is right here, okay, on the graph, okay. Can I identify, so what happens when you, this is a relative what? Max or min? It's a relative max right here, okay. If I flip it, that relative max becomes a what? Relative min. So where would that point be on the blue graph? Yeah, so it's right here. So this is the same point. So I have to pick some kind of anchor point. When I flip this thing around, this point is the same as this point on this graph, okay? You see that? Okay, if I were to turn this point upside down, this point, that it's a maximum here, but when I flip it, it's going to become a minimum. So I'm saying this function transformed. So wherever this point was, it has now moved over to here, okay? So where is this point originally? What's this point? 1, 0. So that's where that point is sitting originally, okay? How do I travel to get this point over to here? What do I have to do? Yeah, so I have to go, to get from here to here, I have to go left 5 and up 2. Okay? How do I travel left 5? What is that? Or all I have to do is write this. This is left 5 and what? Up 2. Okay? So that one is, it's the same skill, but people, you got some visualization that has to go on here. Okay? The key thing is to identify some point that you know. Now why do I not pick this point? I mean, it's going to be down here, but why don't I pick that one? It doesn't fall on a what? On an integer. So I don't know. This is what? This is negative 2 point something, 3 point something. So it makes it harder to go to that. So I pick a point that I know falls on the grid. Okay. So this point is right here. I can match it up to where it translated. Now, likewise, you could pick, say, okay, well, this point, that one's a little bit harder to identify because it doesn't have something identifiable as like the top of a peak or the low of a valley, okay? So pick something that's identifiable to do that. So what we should be able to do now is the transformations I did in class, where we started out, where I give you something like this on a chart, and then the ones that we did graphically, okay? Let's wrap up with these and make sure that we're sort of good with this skill. So, Ja'Cory, what about this one? Reflection? No. Horizontal? No. Vertical? Yeah, down 5, okay? To identify that it's a horizontal shift, these x's would have to become x plus 1s or x plus 2s, and then it would be cubed, okay? Looking at the next one, has it been reflected? Yes. And then did it move horizontally? So I got to figure out what could turn an x plus 1 into an x. Right, minus 1. What could turn an x plus 2 into an x plus 1? What could turn an x plus 3 into an x plus 2? So I'm doing the same thing. What does minus 1 moves me where? To the right. So this shifted to the right by 1, and then that negative 1 on the tail tells me what? It moved down by 1. Okay? So with the exception of having to look at this in the parentheses, this should feel pretty familiar territory for you. And then I think we've got a graph, and you guys can be done and take a look at the homework. So to get from here to here, has it been reflected? Yeah, I mean, your key is it starts down and ends up. It starts up and ends down. So this has been reflected. Okay. Now, how do I pick? What point do I want to pick? So I've just got to find some point on this graph that I can identify where it lives on the other graph. Okay. So this is a nice one. Anytime you have 0, 0, that's a good one. Okay. So this point is sort of halfway between this peak and valley. That corresponds to this graph right there. Does everyone see that? That's the same point. Because you think of if I go up, I hit that point. Down, down, that's the same point. Okay. Then what I will typically do is, okay, where is this point? 0, 0. So what would be the navigational way to get from this point to that point? Okay, you go left 1, up 1. Okay, left 1, up 1. Okay, and that should be it.